Okay. All right, so it's going to start recording any second here. So again, once again, I apologize. We're not going to have the recording from Monday, but moving forward, I will try to do a better job of remembering so that way this doesn't happen again. And yeah, okay. So let's just go ahead and jump into the last quiz. And again, just the one particular problem that I just wanted to look at. So for number two, we had polynomial distribution, right? We had a binomial, it was being squared, and it looked like this. We had x plus 1/4 squared. And the question said expand, which is another way to say distribute or multiply, whatnot, right? Okay. What I saw a lot of people doing, and this is, again, a very common mistake, but it's a mistake nonetheless that we have to look at, is I saw people considering this square and saying, okay, well, I just distribute the square to each piece. And their final answer, which again, I'm going to write in red just to really show this is not the correct answer. What they wrote for their final answer was x squared plus 1/4 squared, which gave them x squared plus 1/16. Okay, who can tell me what's wrong with this? There's one thing in particular that's very wrong. Yeah, Katrine.
You have to FOIL it.
You have to FOIL it, yeah. And why do we have to FOIL it? What's missing here? You don't have to tell me exactly what it is, but there's something missing, right? So try to, just give me your best guess of what this thing would look like that we're looking to get. Raven? Yep.
I don't know if it's quite what you're looking for, but shouldn't it be like the squared, shouldn't that be like 2x plus 1/4?
Yeah, so exactly. So what we're looking for is we're looking for this middle term, right? And the reason that you're going to get this middle term is it all just goes back to the blueprint, right? We looked at our three most common blueprints for binomials. There's a plus b squared, a minus b squared, and then there's the difference of squares, right? A plus b times a minus b. So we look at what we have here, and we have two different numbers, right? X and 1/4, and it doesn't necessarily matter that we don't know what x is. X is just some number, right? So we have two different numbers being added, and their quantity is being squared, right? So we actually fall in the blueprint a plus b squared, which means you could avoid foiling altogether if you just remember what the outcome is supposed to look like. And the outcome is supposed to look like a squared, right? So we're going to have this term. All the way at the far end, we're going to have this b squared term. And if you notice, this is exactly what we have so far, right? We have the x squared, which is our first number being squared. We have the 1/16, which is our last number being squared. But there's this middle thing that we're looking for. And what we're looking to get in the middle is also this plus 2ab. Right, and this is our now complete version of this blueprint. When you have any two numbers whose quantity is being squared, after they're being summed, the quantity is being squared, you're always going to end up with a squared plus 2ab plus b squared. So we look back at this answer over here and we say to ourselves, oh yeah, we're very clearly missing a term, right? We should have three in total, right? 1, 2, 3. You should have three terms. But instead, we only have two terms, the x squared and the 1/16, which again correlates to our first and last terms being squared. So we're missing this plus 2ab. So without doing any work whatsoever, because again, we know what a is and we know what b is, right? Again, we assigned a to be x, we assigned b to be 1/4. I can just tell you for free that to correct this, you can just add a plus 2 times x times 1/4, just like Raven was saying earlier. And when we simplify this, 2 times 1/4 is, of course, a half. So we could actually just rewrite this as x over 2. And now this is officially complete, right? Now we can say, okay, yeah, we've done our distribution. If you did it, via foiling, fantastic. And you end up with x squared. And generally we throw the x before the constant. So just reading it that way, x squared plus x over 2 plus 1/16, right? And it all just has to do with this blueprint that we set for ourselves. A plus b quantity squared is equal to a squared plus 2ab plus b squared. Now, say you forgot the blueprint. Well, that's totally okay, right? Going back to how Katrine answered, we need to FOIL. Foiling is what we learned, right? Or you could think about it as just, distributing one binomial to the next. So what that means for us is we're not going to just apply the square to each particular piece in the parentheses, we can rewrite this, right? We can say this is the same thing as x plus 1/4 times x plus 1/4, right? That's what the exponent is really doing, right? It's taking whatever the exponent is being applied on and telling you to multiply it against itself that many times. So in this case, x plus 1/4 should be multiplied against itself twice, because that's what the exponent number is, right? We have a 2 for an exponent. So now what we can go ahead is we can go ahead and do our foiling just like we learned. So FOIL means first, so x and x, which gives you x squared. Then we have our outside, so x and a fourth, which gives you plus 1/4 x. Then we have, again, our inside, which gives you the exact same term. So we get our another plus 1/4 x, or you can always throw the x in the numerator. It makes no difference. You could rewrite it as x/4 instead of 1/4 x. However, whatever makes sense to you. And then last but not least, we have 1/4 times 1/4, which gives you 1/16, right? And notice how we have these terms that we can go ahead and condense together. So when we condense them together, we get x squared plus, and a couple people left it as 2/4 x. I'm not going to, break your back over this. If you left it as 2/4 x, just try to remember for next time to reduce fractions. But our final answer should be 1/2 x plus 1/16. Okay, so notice the difference between this and what the answer that I was getting from quite a few of you, which was x squared plus 1/16. We're missing this middle term. And the reason we're missing that middle term is because we didn't FOIL, or because we didn't properly distribute all of the different terms. Okay, any questions with this? I just want to make sure we all understand how to distribute binomials, how to FOIL if necessary, if that's how you want to remember it. But just however you remember it, I want to make sure that we're all arriving at the same answer here. Okay, so with no questions, I'm going to go ahead and proceed to the actual homework from the lecture. There is one last note that I want to make a note of. For a few of you, you did get the right answer, or you came very, very, very close to getting the right answer. I'm not a huge stickler, but I saw a couple people write things as 1/2x instead of 1/2 x. Note that these are different. This is not the same thing as that. So just be really, really careful where you're placing that x, because if your x is in the denominator, then that means 1 is being divided by 2 times x. If your x is not in the denominator, that means 1/2 is being multiplied by x. Two very different numbers, at least most of the time. Okay, so I just want to make sure that we're okay with that. Just be careful on your positioning of the variable. Okay, so that's all I wanted to go over about the quiz. If anybody else has any questions regarding the quiz or regarding your grade on the quiz, please feel free to reach out to me. Even though we don't have office hours today, you can still email me or just hang around after class and we can definitely talk it out. Okay. All right, so with that being said, let's go ahead and move on to the homework. So again, homework was on roots, radicals, trying to, take care of that sort of stuff with rationalizing. So what questions do you all have for me?
Can you go over 132?
132, absolutely. Can we table 132 just for a second? Because that's a good one, and I was planning on doing it anyway, and I wanted to show that there's 2 different ways that we can go through it. So hold that question, and we'll absolutely double back to it. Any other questions other than 132? Okay, so what I want to do is I want to just take a look at a couple, ones just to really get, the brain juices going. Kirsten, that saw the hand go up, was that a question regarding a certain problem?
Oh yeah, could you go over 73?
Yeah, absolutely. Okay, so 73 is a good starting point. So with 73, we're discussing the concept of rationalizing. So let's write out what we have to start with. We have a couple variables, right? We have x and we have h. But note that when we're really dealing with rationalizing, it really doesn't matter what the variables are. It actually doesn't even matter what the numbers are. You're going to use the exact same process that you use for rationalizing basically anything whenever there's square roots. So we have this square root of x plus h minus square root of x. And on the bottom, we have basically the same terms. So square root of x plus h. The only difference is we have a plus here, right? So plus square root of x. Okay, and you always have to be very cognizant of what the directions are asking of you, especially when it's, saying rationalize. Because note that we could, if we wanted to, we could rationalize the denominator, or we could also rationalize the numerator, right? Rationalizing just means essentially clear all of the radicals. If you've gotten rid of all of the radicals, then you've rationalized that. And I believe I said it in the lecture, but just to double down in case I didn't, please note that you're not doing anything incorrectly if you rationalize one and you still have square roots in the other. There's no way to avoid that. If you rationalize the denominator, you're always going to end up with square roots in the numerator. If you rationalize the numerator, then the contrary is true, right? You're going to have square roots in the denominator, and that's just the name of the game. That's just how this goes. Okay, so don't think you're going down, this deep dark down road. If you still end up with square roots, what matters is that you're following the directions and you're rationalizing the specific area. So for 73, we're supposed to be rationalizing the denominator, right? So we're going to focus our attention mainly down here to the square root of x plus h plus the square root of x. Okay, so for rationalizing, there was a certain term that I threw at you in the lecture, and it was called the conjugate pair, right? Conjugate pair. So we're looking for a pair of numbers which are already given to you, but there's going to be one slight difference between what we're given and what we're going to multiply by. So does anybody have any ideas what we're going to multiply the denominator by? So that way we can try to start this process.
X squared.
Okay, so if I multiply by an x squared on the bottom, note that it's going to be really tricky to combine this x squared with the square root of x, right? That's not going to clear the square root. And also on top of that, we also have to apply the x squared to that other term as well, right? So that's really not going to clear the square roots either. So let's keep that in the back of our heads and, try to find something else. Kirsten?
The same thing, but with a negative.
Yeah, same thing, but with a negative. So what we're going to multiply by, I'm just going to put it in blue here because this is the conjugate. So what we're going to multiply by is square root of x plus h minus the square root of x. And notice that's actually what we have in the numerator, but that's okay. We can totally leave it like that. And, that's for the purpose of what we're doing. This is the correct approach, right? And the reason that we're multiplying by this is, of course, the conjugate pair. Conjugate pair is when you just essentially take the exact same numbers and you flip the sign between them, right? So we still have the same numbers, square root of x plus h and square root of x plus h. We have the square root of x and the square root of x. And the only difference is, note again, we have the addition instead of the subtraction and vice versa. And the reason that we're doing that is, again, I tried hinting at this in the lecture, but if you remember difference of squares, well, a surefire way to make sure that, your ending result is two numbers being squared, which is exactly what we need, right? We need these numbers to be squared so that way we can clear the square roots, right? If just going back, we know that if you had square root of x squared, we know that the square root and the square are going to cancel, and we just end up with x, right? This is essentially our goal for rationalizing. So with difference of squares, we know that, writing this out one more time, a plus b times a minus b is equal to a squared minus b squared, right? And this is our goal. We want these two numbers to be squared, just like I just spoke of, so that way we can get rid of the square roots. And so your job is essentially just figuring out what you have. Do you have the a plus b or do you have the a minus b? And in this case, of course, it becomes pretty easy to figure out, right? This we can just call a, and this we can call b if we wanted to, and note that we have this addition going on. So all we have to do is multiply by a minus b, which is, again, the same exact numbers, but just with this, minus sign between them. So the last thing that we have to do is remember that whatever we do to the bottom of a fraction, we also have to do to the top, right? We're not trying to change the value. We're trying to change the appearance of it. If we change the value, then this is a totally different fraction. We can't do that without being inside of an equation, which we'll look at later. But for the purpose of this, we are not allowed to change the value. So by multiplying by square root of x plus h, in the minus square root of x in the bottom. We have to do the exact same thing up top. Okay, so let's go ahead and figure out what is going to happen here. It might be helpful for you to draw parentheses if you need it, just to understand exactly what is being multiplied against what. So we see, just including these set of parentheses, we have a binomial times a binomial. And you might be thinking, oh, great, we have to FOIL, right? But luckily for us, we have our blueprints, so we don't really need to do that. In fact, for the denominator, we actually know exactly what we're going to get. And we know that because of our game plan all along, right? The reason we're multiplying by an a minus b is because we had the a plus b. So if this is a plus b, and we're multiplying by a minus b, I should get guaranteed a squared minus b squared. So now it's just figuring out what a is and what b is, which we just assigned earlier, right? So what should my denominator look like? Somebody help me out.
2x plus h.
2x plus h. Okay, so careful, right? We're talking about a minus sign here, but let's try to break down your steps to get there. Kirsten, if you want to help me out one more time here.
Is radical x plus h squared minus radical x squared?
Yeah, perfect. So we have our a, which we assigned as radical x plus h, right? And of course, it's being squared because of the difference of squares, right? We arrive at this conclusion, a squared minus b squared. So we have that. We know there's going to be a subtraction. So we have this minus sign there. And then b, which was just square root of x. So we have square root of x, quantity being squared. And now let's go ahead and try to figure out what the numerator is going to be. But notice that we actually have the same exact terms twice, right? We have a minus b and another a minus b. Well, if I have the exact same term being multiplied against itself, I can just rewrite that as a minus b quantity squared. But what's this for my blueprint, right? My blueprint says, okay, well, I know I'm going to end up with an a squared. I know I'm going to end up with a b squared. And the only difference between this and a plus b is the sign of the middle term, right? We just talked about this in regards to the quiz. The only difference is instead of a positive 2ab in the middle, we get a negative 2ab in the middle. Right? And so again, we just figure out what a and b are, but a and b, again, we assign those values, right? A is just the square root of x plus h. B is just the square root of x. So with all of that being said, we know what the numerator is going to come out to be without doing any sort of foiling. Now, you can do foiling. I want to stress this, okay? You absolutely can FOIL. You can do your normal distribution. You'll end up with the exact same thing. It's just oftentimes a lot easier that if you can memorize this, note that we're going to avoid a lot of the hassle of dealing with these square roots and trying to, multiply one against the other and figuring out what that becomes. Okay, so just like Kirsten had said earlier, we're calling a, square root of x plus h, right? So we know that the first term in our numerator should be square root of x plus h squared. So square root of x plus h squared. Okay, we have this middle term of minus 2ab. So we have minus 2 times square root of x plus h, which is your a, and b, which is square root of x. And then we have our last term, which is plus b squared. And again, b is our square root of x. So we have a plus square root of x squared. And now all we have to do is just simplify down. And once everything is simplified down, we have our answer. And that's it. So let me go ahead and make some space so that we can zoom in a little bit and make use of this tablet. There we go. Okay, so let's handle the denominator first because the denominator is going to do some nice cancellations and we'll see what happens. All right, so denominator. I have the square root of x plus h quantity squared. What should happen here? What should this first term come out to be? Elise? Yep.
Shouldn't it just be x plus h?
Yeah, exactly. Because we see that the square is going to cancel with the square root. So we're just left with x plus h. Fantastic. And Elise, if you just want to help me out with the next one as well, what does this become for down here?
X.
Yeah, it's just x, right? And again, we see the same thing. We see the square and the square root canceling out. So we see that we have x plus h minus x in our denominator. And it becomes pretty easy to see that the x's are going to cancel, right? We have a positive x, we have a negative x, so those terms are just going to blow away, and all we have left in our denominator is just a single lonely h. And now, before you even proceed to the numerator, because again, remember what the directions were, right? The directions were rationalize the denominator. So whatever happens in the numerator happens. That's, you want to make sure you try to get the right answer up there, but you also want to make sure that you're on the right path. So, did we rationalize the denominator? Absolutely. Yeah, even though there's just one term left, that's totally fine. The idea of rationalizing was just to get rid of the square roots in the denominator, right? We had a square root over x plus h, we had a square root over x, and note that when everything is said and done, after the work that we've done, we don't have any square roots in the denominator anymore, right? We just have h by itself, which is totally okay. So that should be a great indicator for you to keep going. If, however, you ended up with, just hypothetically, a square root of h here, then you're either going to need more work to, finish this problem, or you kind of went down an incorrect path somewhere along the lines and you should review your work, right? The idea is to just end up with just the one term without any roots being held over it. Okay, so now what we're going to do is we're going to do the exact same thing, just, up top. So what we're going to do and what we're going to see is a lot of the same exact cancellations. Just because Elise already helped us with this, I'm going to do the same thing. So we see that the square is going to cancel with the square root here. So we have an x plus h. We see that, again, the square is going to cancel with this square root. So all the way at the end, we see that we have this plus x. So we just need to figure out what's going on in the middle. And in the middle, there's really not a whole lot that we can do, right? We see that when we multiply these square roots together, and it's also very important to remember, we can only multiply radicals together when they share the same indices, right? In this case, they're both square roots. The hiding index is a 2 right there. Same for the other one. So we can multiply them together, but it's really not going to simplify too much. So multiplying them together just means I'm just going to combine them into one singular square root. So I have x times x plus h inside of that square root. Okay, there's only one last step that we have to do here just to simplify. We see that we have one x over here. We have another x over here. So we should just combine them together and see what we get. So our final answer should be 2x plus h minus 2 square root of x times x plus h all over h. Note that, again, there's nothing that you can do here, right? If you actually do the distribution of the x times the x plus h, you get an x squared plus an xh underneath the square root, but that's it, right? You kind of get roadblocked. There's a wall there. There's nothing else that you can do, so you can just leave it like that. I only recommend distributing when you can actually simplify further, or, of course, if the directions say distribute. But note that that term is basically done. There's nothing else that we can combine with our h, so that's done. And there's nothing else that we can combine with our 2x, so that's also done. And voila, we see that h, again, in the denominator is all by itself, no square roots. So we've accomplished our goal of rationalizing the denominator. Right, so just to recap what we did here before I ask if anybody has questions, we started with this fraction way back over here, right? And this fraction looks menacing, but what you're going to do hasn't changed, right? You're going to follow the same exact policy. You're looking for the same numbers. So in this case, square root of x plus h and square root of x. So you're going to keep those numbers the same. You're going to be multiplying by those numbers. The only difference is the sign, right? We're multiplying by the minus sign because we were given the plus sign. So we're multiplying by the conjugate pair. Multiplying by the conjugate pair always results in the a squared minus b squared template. And as a result, we see a lot of cancellations happening in the denominator, right? The square roots cancel with the squares. We have the x plus h minus x, and those x's just drop out. So we're just left with the h in the denominator. Similarly, we have the x plus h minus square root of x, and the square root of x plus h minus square root of x again. So we knew that this would give us something in the form of a minus b squared, which, again, if you just remember the template, then you know exactly what's supposed to come out. But even if you don't remember the template, it's okay. You can FOIL and you'll get the same answer either way. So we end up with this kind of nightmarish looking answer in the numerator, but don't let that make you think that you haven't done the correct steps, because whatever happens in the numerator happens when you're trying to rationalize the denominator. Okay? Yes, Chris.
In calculus, actually, a lot of the answers to some of the stuff we had to do, that is a perfectly acceptable answer right there.
Yep, absolutely. Any questions on this? I just want to make sure we all understand the policy of what we're doing with conjugate pairs, with rationalizing in general. Are we all good with this one? Okay, so let's go ahead and move on. Okay, again, I know that I have to save some time for 132, which I'm going to do. Any other questions other than 132 before we get to that? We still have time for maybe like one more decent question.
Can we do 112? I tried to do it, and I think I did something really wrong somewhere.
Okay, sure. Yeah, 112, absolutely. Okay, so let's go ahead and take a look at 112 together. I should probably know what 112 actually is. Okay, there it is, found it. All right, so 112, we're given the following. We have 49 underneath of a fourth root, right? Again, note that the index is not a square root. This is a fourth root. And we also are multiplying against it the square root of 7. Okay, so the directions say convert the radicals to exponents and then simplify. Well, what does that mean for us? If we're converting, radical to the exponents, well, that basically says we're taking a look at the powers of this index here, and we're taking a look at the power of the numbers, right? So everywhere that I just circled, this is where you're focusing your attention in the beginning. We're trying to look at the powers of the index versus the powers of the numbers. Now, in this case, both of the numbers just have a power of 1, right? When the power is not visible, when it's hiding, essentially, we can just say, oh yeah, this is to the first power. So that doesn't, really require much finding out. It's just kind of given to you. And again, also, we know that 7 is underneath of the square root because when the index is hiding for a radical, we assume this to be a square root. So great, we know the powers, we know the indices, we just need to properly rewrite these things, right? So we know that our bases aren't going to change. This is still going to be 49, and this is still going to be 7. We just need to figure out how to properly translate the radicals to the exponents. So does anybody happen to remember how we do that? Let's start with 7 first and see what we can this one over here. Haley, yep, if you want to help me out.
It would be to the 1/2 because you would take the 2 from the outside and put it as the denominator, and then the 1 from the inside as the numerator.
Exactly. Perfect. So when we're translating radicals to exponents, the reason that we have to take into account both the power of the index and the power of the number is because they translate directly to the fraction or the rational exponent that we're going to get. Note how the power of the number or the power of your base directly translates to the numerator of your exponent. And conversely, or similarly, I suppose, similarly, we see that the index of the radical becomes the denominator of our exponent, right? So 7 is to the first power, so we just write a 1 up top, and it's a square root, so we know that it's to the 1/2 power. Okay, great. So thank you, Haley. We're going to go ahead and clean that up. And with that being said, I'm just going to go ahead and do 49 as well, because it's the same exact thing, right? We're just going to go ahead and take our power, which is, in this case, again, 1. So we have a 1 over here, and then it's to the fourth, right? The index is a fourth root, so it's 1 over 4. Okay, now remember basically everything that I just said earlier and in the lecture, which was we can only multiply numbers together when they have the same powers. If they don't have the same powers, then we can't multiply them, right? If I gave you, for example, 2 cubed times 3 squared, you can't multiply these numbers together initially, at least. You can obviously do the operations where you do 2 cubed times, and then you do the 3 squared, and then you multiply them together, but you can't multiply the 2 times the 3. But if, however, this were, we'll keep this as a 2. If, however, this were 2 squared, well then, yeah, you absolutely can multiply them together. Why? Because this is the same thing as 2 times 3 quantity squared. And then, yeah, you can multiply the 2 times the 3, you would get a 6, and you get 6 squared, which would give you the same exact answer, 36, which would give you the same answer as if you did both of these operations separately, right? 2 squared, which gives you 4, 3 squared, which gives you 9, 4 times 9 is 36. So either way, you get the same answer, and note that you can only do that because of the fact that the powers are the same. So we go back to our actual homework question, and we look at our powers, and we have a 1/2 power and a 1/4 power. So right now, these powers are different. We have to do some kind of manipulation so that way we can get these powers to be the same. So I'm going to leave the 7 to the 1/2 power alone. The reason that I'm going to do that is because most of the time, any kind of manipulation that I'm going to try to make to the exponent also requires some kind of manipulation to the base as well, right? So if I keep my 7 to the 1/2 power away from this, then we'll just deal with that after we're done doing our manipulation to the 49. So 49, we can always rewrite as 7 squared, right? We know 49 is a perfect square, so great. If we rewrite it as 7 squared, that's totally acceptable. So what I'm going to do is I'm going to rewrite this, what we have so far, as 7 squared to the 1/4 power times 7 to the 1/2 power. Okay, so now this comes back down to our original exponent rules. What do you do when you have a base raised to an exponent raised to a second exponent? How do we handle this situation right here? Anybody remember? Emily McDavid, do you happen to remember? McDavitt, sorry. Okay, so our policy whenever we have a base raised to an exponent raised to another exponent, right? When we have a to the n raised to another one, raised to some other exponent, we'll call it m. What you always do, regardless of your base and regardless of your exponents, is you keep your base the same and you multiply the exponents, right? You get n times m. So what we're going to do up here for what we have 7 squared to the 1/4 power. So what I'm going to do is I just multiply the 2 times the 1/4. Okay, so multiplying 2 times the 1/4, that would give me 7 to the 2/4 power, right? 2 times a fourth gives you 2/4. And we still have this 7 to the 1/2 that I'm carrying down with each step. 7 to the 2/4, we of course know that we can simplify that fraction, so this is just another 7 to the 1/2. But now wait, we have the same base, right? We have the same base being multiplied against each other. What's our policy for this? What do our exponent rules say? If we have the same base being multiplied, what do we do with the exponents? So if I have x to the a times x to the b, what should my answer be for this area right here?
X to the a times b.
Nope. So Nico, help me out.
X to the a plus b.
X to the a plus b, exactly. The multiplication of the bases implies addition of the exponents, right? So we would end up with x to the a plus b. It just means we keep the base the same, we consolidate it as just one singular base, but we add our exponents together. So, okay, well, what are we going to have here then? If we have 7 to the 1/2 times 7 to the 1/2, we keep our base the same, so we have 7, and then we have 1/2 plus a half, right? So 1/2 plus a half. And what's a half plus a half? Well, that's just very clearly 1, right? A half plus a half is 1, so we get 7 to the first power, and we know that any number to the first power, we can just omit that first power and just write it as the number itself, right? So we end up getting just 7 back. Now, I do want to stress that this step right here might not be immediately recognizable. You might be wondering where I got this from, to translate the 49 into the 7 squared. The reason that I do that is because this base over here kind of gives you a hint of what you're looking for. Remember, all of this is just dealing with exponent rules, right? Even though they're rational exponents, which means, even though the exponent is a fraction, we saw that it follows the exact same rules as regular exponents, right? When they're integers or natural numbers. So with that being said, if I can get my base on for the left number right here to also be a 7, then I know that I can use my exponent rules to combine the bases, just make it one base, and then just add the exponents together, right? And that's exactly what Nico helped us out with right down here, right? We saw that we had the two bases, or I'm sorry, we saw we had the same base twice, right? 7 and 7. It was being multiplied, so we know that we can use our exponent rules to add together. So that's where this translation of 49 to 7 squared is coming from. Now, I also want to note that there's a different way of doing this. You can also try to manipulate the 7 instead of manipulating the 49, but it's needlessly annoying to go through that process. I think it's a lot easier to see that 49 is 7 squared than to try to say 7 is 49 to the 1/2 power, right? So you could also have tried to manipulate this base instead and said 7 is 49 to the 1/2 power, and then note that you would have the same base either way, right? You'd have this base of 49, you'd have this base of 49, and then you would apply your normal exponent rules either way. But again, I think it's just a lot more intuitive to change this number from 49 to 7 squared because we know that 49 is a perfect square. Okay, so any questions with this? This was just a lot of exponent rules. Yes, Elise.
If you just did 49 to the 1/4, like you solved that, and then you did the 7 to the 1/2, and then you multiplied those two, would you still get 7 or no?
So are you saying like basically right at this point right here?
Yeah, like if you like solved like each one of those and then multiplied them together.
Okay, so then my question for you becomes, what is 7 to the 1/2 power?
I have no idea.
Exactly, right? It's 7 to the 1/2 power. We translated from the radical, right? So we could rewrite that as just, square root of 7. And how, without the use of a calculator, how does anybody possibly know what square root of 7 is? You can get a decent approximation of what square root of 7 is, right? And the way that we could approximate is, that square root of 4 is equal to 2, and that square root of 9 is equal to 3. So that square root of 7 is going to be approximately somewhere in the ballpark of like 2.6, right? It's a little closer to 9 than it is to 4. So it's going to be a little closer to 3 than it is to 2. But that's not really giving you an exact answer, and that's not going to help you with the other one, right? And I don't even ask me to try to figure out what the fourth root of 49 is, right? If I gave you that, I mean, yeah, this would just be untenable to ask from anybody. So yeah, in theory, if you had a calculator, you could absolutely plug in, 49 to the 1/4 power. It spits you out some, decimal, some number, and then you can multiply that against square root of 7, and yeah, you'll get 7 back as your answer. You'll get this number right here. But it's all about trying to figure out, how we do it without the use of a calculator, right? So yeah, if you got to this point and calculators were allowed, then sure, have a ball. But this is our process for doing it without the use of, other tools.
Okay, thank you.
Yep. Okay. Any questions on this before I move on? I just want to make sure I leave time for 132. Okay, let's go ahead and hit on 132 then, and we're going to see the two different methods that we had available for us. One of them is pretty much how I imagined most of you would have gone, like 99% of you. And then the 1% of you who tried the other method maybe, saw that it was possibly challenging, but it actually comes out to be the exact same method either way. So let's go ahead and take a look. So we are given x squared plus 1 over x squared. And the question says we want to show that this is equal to 34. And we're also given that x is equal to 3 minus 2 square root of 2. So these are our two pieces of information. We're given this knowledge of what x is, and we're trying to show that x squared plus 1 over x squared gives us back 34. Okay. So the first method, which again is the method that I imagine many of you would have taken, which is just directly substituting in. Because we know what x is, you can just plug x into your x squareds, right? Just here and here. So let's take a look and see what that comes out to when we do it that way. So doing it that way, we see that we have 3 minus 2 square root of 2 quantity squared. And then we have 1 over the same exact thing, right? 1 over 3 minus 2 square root of 2. Okay? So we want to try to find a way to consolidate these numbers and, make them, right now we have, this fraction. When everything is said and done, we're going to have, some sort of integers or some sort of numbers over here. We want to try to find a way to, kind of put them together, right? But before we do that, we should probably just figure out, oops, sorry, I just realized I wrote that without the square, my mistake. So before we do that, we want to just, simplify as much as we can before we even try to find common denominators, right? If we try to find a common denominator now, we're going to be putting this over 3 minus 2 square root of 2 squared. And then, whatever we do to the bottom, we also have to do to the top. It just becomes a mess. So what we're going to do is we're going to simplify things first, and then we'll worry about the aspect of adding a fraction to it. So simplifying, we have, and just with the essence of time, I'm just going to go a little bit quicker here. We see we have the form a minus b squared, right? Where a is 3 and b is 2 square root of 2. We have two different numbers, subtraction between them, and their quantity is being squared. So using the template that we have for that, we know that we should end up with a squared minus 2ab plus b squared. So with that being said, let's go ahead and fill that out. We know that we're going to get a squared, which again means 3 squared, which gives us 9. We're going to have minus 2 times a times b, right? So minus 2 times a, which is 3, times b, which is 2 square root of 2. And then we're going to have b squared, and b squared is 2 square root of 2. So we're going to have over here 2 square root of 2 squared. And that's all just coming from our template. Then for the other side over here, for the fraction, note that because we have the exact same number, right? We have x squared, and we also have the x squared in the denominator. It's the same number squared, right? So all the work that we just did, we can just repeat, but just in the denominator, right? So this is also 9 minus 2 times 3 times 2 square root of 2 plus 2 square root of 2 quantity squared. Okay? Let's go ahead and try to simplify things again. So we have over here, we have this 9. 2 times 3 gives you 6. And 6 times 2 gives you 12. So we have 9 minus 12 square root of 2. And then for this one over here, the way that you handle 2 square root of 2 squared is you apply the square to each piece, right? Note that this is different because 2 and square root of 2 are being multiplied against each other, which means that you can absolutely apply the square to each piece. If this were instead 2 plus square root of 2, then you would have to do foiling because it would be a binomial instead. So we have 2 squared and then square root of 2 squared. 2 squared gives you 4. Square root of 2 squared, well, that would just cancel with the square root, which gives you back 2. So you have 4 times 2, which gives you 8. So we have 8 over here. And again, all the work that we do for the one on the left, we can also repeat for the denominator of the fraction. So we have 1 over 9 minus 12 square root of 2 plus 8. Okay, moving down, we see that we have 9 plus 8, which gives us 17 minus 12 square root of 2. And we're going to make that same addition in the denominator here. So we have 17 minus 12 square root of 2. And it's at this point that we would probably be trying to take care of this denominator here. And the way that we do that is the way that we've been handling it for the rest of the homework, which is rationalizing, right? We see that we have the square root of 2. I don't want the square root of 2 here anymore. So I'm going to rationalize the denominator. And what that means is I multiply it by its conjugate. So I'm going to be multiplying this fraction by 17 plus 12 square root of 2, right? I keep the numbers the same. I just flip the sign. That's what I'm multiplying by. This is the conjugate pair. And whatever I do to the bottom, I know that I also do to the top. So I also multiply by 17 plus 12 square root of 2. Okay. So we're just bringing down this 17. We're bringing down this 12 square root of 2. And for our numerator of our fraction, we see that, oh yeah, whatever we multiply this by, we're multiplying it by 1. So that's just going to directly transfer over. So we're going to have plus 17 plus 12 square root of 2 on top. And on the bottom, well, again, note that we now, by multiplying the conjugates, we have a minus b times a plus b, which is difference of squares. So because of difference of squares, we know that we can just square each of those individual numbers and throw a minus sign between it, right? Difference of squares says we should end up with a squared minus b squared. So I should end up with 17 squared minus 12 square root of 2 squared. And at this point, I would definitely just recommend either doing some scratch work and figuring out what 17 squared is or pulling out a calculator. But either way, however you come to, figure that out, we end up with 17 minus 12 square root of 2 plus the numerator remains unchanged, right? So still 17 plus 12 square root of 2. And in the denominator, 17 squared actually gives you 289. And then remember how we handle this piece here being squared. You apply the square to each particular piece, right? So you're going to have 12 squared times square root of 2 squared. 12 squared is 144. Square root of 2 squared is just 2. So you basically have 144 times 2, which is 288. Well, wait, 289 minus 288, well, that should just give you 1. So you actually end up with this here, where you have 17 plus 12 square root of 2 over 1, which means this entire fraction drops out, right? You can divide anything by 1 and just get that number back. And now it actually becomes pretty clear to see that this term cancels with this term. You're just left with 17 plus 17, which gives you 34. Okay, so I know that I talked through that really, really fast because, just for the sake of time, I don't want to hold anybody too long, but this was the method of showing a direct substitution, right? So we knew that x was the 3 minus 2 square root of 2. We just plugged that directly in for x and then did whatever manipulations we needed to do and to make our lives easier here. Once we got to this point where we had this 17 right over here, so once we got to this point where we had the 17 minus 12 square root of 2, we just conjugated it. We use the rationalization methods, so that way we can get something in the numerator, and very nicely enough, 17 squared minus 12 square root of 2 squared just comes out to be 1. So everything in the numerator divided by 1 is just everything in the numerator. So then we see here that this term cancels with this term. You're just left with 17 plus 17, and in fact, we have now shown that we get 34 back. What I'll do, because I did mention that there was a second method and I didn't have enough time to get through the second method, what I'll do is I'll post the second method on Blackboard. I'll post it in the homework section. I'll very clearly label it as solution so that you can take a look at if you want to. It's totally voluntary, but you can take a look at it and see that there is in fact another method that we can take, which just involves using our blueprints, using the templates that we've been talking about literally from week 1, right? So in this case, just to get the ball started, note that we have some square plus another square, right? We have x squared plus 1 over x squared. So it just involves a lot of, a little bit of manipulation to get it into the proper template. But once we get it in that template, the numbers actually get a lot lower. So instead of dealing with, like 17 squared and 12 square root of 2 squared, we see that the numbers are actually greatly reduced, making our lives significantly easier. So I'll post that on Blackboard. I'll have that up in a couple hours. Your next lecture and next homework will also be up. And remember that your next quiz is next class. Okay, so I'm going to stop the recording here. If anybody has any questions for me regarding the last quiz or regarding the material, just hang around and I will be more than happy to speak with you. Otherwise, have an excellent rest of your day.